The logo sir. Yes, ma'am. 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 Oh, okay, ma'am. Thank you, ma'am. Thank you, ma'am. Okay, ma'am. Yes, ma'am. 3D model, 3D model frame and one-way slabs and two-way. Yes, ma'am. Sorry, ma'am. After I tell you, after. Uh, okay. Okay, ma'am. Okay. Okay. Ma'am. Uh, Good evening. Thank you. Good evening to one and all. Today we'll discuss about how to create the one 3D framed structure, right? Today we'll create the one 3D framed structure and how to create the one-way slabs and two-way slabs, how to give the live loads, dead loads, and other loads for your slabs, right? Okay. I directly present my screen. So my screen is visible, sir. My screen and voice is. Okay, sir. Thank you, sir. Sir, YouTube live also is audible, sir. Okay, okay, sir. We will check after, sir. Okay, sir. Thank you, sir. Okay. Uh, okay, sir. Today we'll discuss about how to create the 3D model, right? Then what purpose I am opening in Revit? Okay. I tell about small basic concept about 3D frame registration before starting, right? Mm. But basically, the some of us knows about how to create the center to center line diagram, right? So many of us know that is a basic concept for creating of a 3D structure, right? How many of you know anyone to how to create the center to center dimension in your building? Only your grid point is taken as a center to center dimension of your building. You design any analyze software, ETAP, STAT, or any SAP or SAFE. You put the number of node point is a center to center of your building, right? Okay. For example, I simply create the one structure, right? One plan. I just taking only 5 minutes. I'll give the importance for STAT only, right? It's okay. Yeah. Simply go for build wall. Then I simply create a one plan, just a 5 minutes, right? This is all of us feet and inches. Anybody wants how to create the architecture and Revit plans and structure means to watch my YouTube channel is available. How to create the plans and other activities, right? First of all, I create a one 10 by 10 room, right? This is my 10 by 10 room. Then I create my 16 by 10. This distance is 16, right? This distance is a 16. I create this 16 or 20, anyone, right? I'd convert as a one-way slab. 20 is our 10, right? Interior 10, right? So, okay. Then I create another one room. It's a 11 by 11 by 10, right? Next one I simply create a one rectangular hall, right? I simply create a one rectangular hall 16 comma 16, right? 16 comma 16, the 16 comma 20 something, right? 16 comma 20. I simply create a one plan. It's a 10 by 10 is a 20 by 10 is come 11 by 10, and this is the 20 by 16 by 20, right? This is 20 by 60, and I simply create another room this type, right? This is I create simply create one room for 20 divided by 20. The speed is 11, right? 10. Then how is our plan, right? Assumption as this is a one room, two, three, four, five. Five rooms are there. This is the first step. Second step is a column marking, right? Second step is a column marking. Before you column marking, how to create the center to center distance? How to create the grid lines, right? How to create the grid lines for your plan? Anyone? Most of us you creating the grid line in AutoCAD, right? Anyone? What are the softwares easy to create your grid lines, center to center dimensions? Anyone? It's okay. I create a simple center to center distance, right? I take this center to center distance. How to create the grid lines means this is the second step for creating the plan, right? Simply go to Dutium, go to grid, right? Grid. Then how to create the horizontal straight line grid? I need the center to center dimension for my buildings, right? I need this 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 columns. I needed 12 columns. Then how to create the center to center dimensions for my columns? Simple. Simply go to grid line, click the center point. Automatically repeat will be taken, right? This is our first point. First of all, I create this ABC is deleted, so it's automatically converted to EFGH, right? This is the next column marking, next grid line, right? This is the next grid line. Says automatically will be created, right? Next, how to increase the outer size? Simply click this. Simply drag this circle, right? Says automatically the x distance is over. Then z distance. Simply go to grid, right? Then this center point, right? This is a h. Then I need this column portion, right? I need this portion. Then this portion. Then I need this portion also, right? This portion. I need this portion, right? Simply click this, drag the center button. Automatically it will be increased. I need this portion also on column, right? Simply drag this portions, right? This is a grid line. This is a second procedure. You simply create in your plan. The second procedure is a forming of grid line, center to center dimension for your building, right? This condition is there. The x direction alphabet, the opposite z direction numbers, right? Simply click this, double click this. I converted into A, right? This is a B. This is a C, right? This direction I need 1 2 3 4, right? This direction, simply double click this 1, this double click this 2, this is a 3, this is a 4, this is a 5, right? This is the second step. First step you simply create the grid lines. The second step is a marking on grid numbers A, B, C. The z direction is a numbers. Once you provided the A, B, C, the opposite direction is a 1 2 3 4. That is a condition for creating of the grid line, right? How to take the center to center distance for your building? Simply go to annotate, then go to dimensions, right? Go to dimensions, aligned, right? Go to aligned wall faces, simply click this. This is my center to center distance, 10 feet 9 inches. This direction is a 20 feet 9 inch, right? The x value is over. Then z direction, this to this column spacing 10 feet 9 inch. Next column spacing 11 feet 9 inch. The next column spacing to the spacing 5 feet 5 feet. Then this column to this column, right? Now understand, this is the center to center distance. You design any commercial project or real estate project, this is the procedure for take the center to center dimension, right? This is center to dimension. How to take the room dimension means simply click this. This is our room dimension. See this, our room dimension is a 10 feet by 10 feet, but our center to center feet is a 10 feet 9 inch. The wall thickness is a 9 inch. This wall thickness, this half 4 and a half, totally 9, right? 10 feet 9 inch. Now understand how to create the center to center grid lines and how to take the center to center dimension. This is the second procedure for your design. First procedure is the creating of a plan and marking on columns. I need this place. I need 1 2 3 4 5 6 7 8 8 9 10 11 12 13 columns, right? I need this 13 columns. Okay, I need this 13. 1 2 3 4 5 6 7 8 9 9 10 11 12 13, right? I need this 13 columns approximately. I take a not a correct plan, this is a small approximate plan, right? Is now understand, this is the method to creating of the grid line. Okay, the next one is the how to apply this values into your stat, right? This is our plan. Simply create the grid lines, right? Simply create the grid lines. Then how to create the node points in your framed structure, right? I already told, this is a direction, right? This column point, see this 1 2 3 8, you need means you will be provided, or 9 10 11 12, right? I provide the corners, right? 12, I take the 12 columns, right? Okay, now understand how to create the grid lines and center to center dimensions, right? Okay, I am directly open the stat. Okay, I am directly open. This is a basic concept. Is the you create the grid lines in Revit means some difficult to create. You create the stat means Revit means it easy grid line creation, right? That is the difference between AutoCAD and Revit. Okay, the same structure. Simply I get a space, then kilometer per meter. Sorry, I converted as a feet, right? Feet, foot or feet by kilonewton. This plan is a feet, right? Yes. Okay, finish, right? Okay, I plan is in foot or feet, right? Okay, this is our next step, how to create the grid points, right? But same procedure, but our first is all are in feet, right? All are in feet. This is the first point, second point, third point. This is fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th point, right? You will be go to means you will be provide that text. The first point is a what point? Anyone? Or first point x is a 0, correct? Yours correct. First point is a 0 comma 0 comma 0. Our second point is a 10 feet, right? 10 feet. Center to center distance between the three lines. Yes, 10 feet 9 inch. Our 10 is a feet, but 9 inch converted into feet. How to convert the inch into feet? 9 divided by 12, right? I con I converted into inch into feet, right? I have 9 inch, right? 9 simply divided by 12 equal to 0.75. I simply enter 10.75. It's a feet, right? Only feet is a 10 feet 9 inch. My 9 inch converted into feet. It means 9 divided by 12. This 3 means 3 inch means 3 divided by 12. Divided by 12. You converted into inch into feet means divided by 12 automatically converts as a feet, right? That is a condition. 0.25 is a correct. You converted 0.25, correct. Okay, the second point is over 0.725. The next point is a anyone this point, same procedure. 20 feet 9 feet. This is yeah, 10 feet 9 inches, 20 feet 9 inches, totally 10 plus 20 is a 30 feet, right? Plus 9 inch means 0.75 plus 0.75 equal to 31.5, right? Or simply enter 31.5. Our x distance is over. Simply see this, automatically created the 3 node points, right? Next one, next point is the fourth point, right? Our fourth point is this point. X distance is a anyone, x is a 0 point, right? This is a basic concept. Z is a what, how Z is a this distance, right? This person Z have a node distance, so it's 10 feet 9 inch, right? 10 feet 9 inch is a Z. Simply go to 10.75. Our next point also same, 10 feet 75. Z is a 10 feet 75 is the same, 31.5, right? 10 feet 75. Enter. I simply created this 2 points, right? This node 6 columns, 6 node points, 1 2 3 4 5 6, right? I created this point. The starting point is a 0, right? Starting x distance is a 0. Simply enter 0. But z is a 10 feet 9 inch plus 11 feet 9 inch, right? This to this distance is a 10 feet, correct? 10 feet 9 inch plus 11 feet 9 inch. That is the distance, center to center distance. This center is a 10 feet 9 inch, but this point is a this to this distance, 10 feet 9 inch plus totally 21 point. Correct. 22.5. Our Z distance is 22.5. The next point is the same point, right? 10.75. Then 22.5. You take a next point is a I do not have no column for this portion. Next point is a which point? This point or this point? This point, right? 1 2 3 4 5 6 7 8. Ninth column is this column. Okay, ninth column is this column. X distance is a ninth column is this portion. Our x 10.9 inch. That is a correct. The starting point is a 0. Some distance is there, right? 10.9 inch. Simply go to 10.75, right? Our Z distance is, that is our this point, right? Our Z distance totally 22.5 plus 5, right? This is our X distance. Next point is this point, right? Z distance is a Z distance. This to this distance, total distance 22.5 plus is understand or not? 22.5 this point plus 27.5. This is a 10 feet 9 inch plus 11 feet 9 inch plus 5 feet. Totally 27.5, right? 27.5. The next point is a end point, right? This point is a end point. Totally 10 plus 30, right? Is a 31.5. Is the distance is the same, 27.5, right? The next point, next node point is this column. Is a 0 or any value? Starting point is a 0, and this starting point is a 0. I simply enter our z direction 27.5 plus 15.75, right? Now understand, this is a total is a 27.5 plus 15.75. 27.5 plus 15.23.25, right? Is the distance is a 20, is the distance is a 23, sorry, 33.25, correct. Next point is a this to this point, x distance is 10 feet 9 inch, right? 10.75, z is a 33.25, right? This is the basic method for creating the node points in your center to center diagram in STAT. You go to E-tabs, any analyze software. This is the basic concept for creating the grid data. Now understand how to create the center line diagram in Revit, how to apply your node points in STAT, right? Now itself, I simply minimize this Revit. Okay, Revit work is over. I simply create a one plan. I simply enter the node points, x direction, z direction, right? Then minimize this node points. I will create the all the points, right? See this automatically. 1, 2, 3, 4, 5, 6, 7, 8, 7, 8, 9. Once again. This node point is 22.5. This is a 10.75. Something 10.75. This point is 0. This point 22.5 and this point, right? Okay, 0, 22.5, this point, then this point 27, and this point also 27 point, and this point 27, and that 2 points, right? Now it's correct, automatically created the correct points, right? Then how to increase the height for your building? How to increase the height, right? First one is a simply created the node points, right? Simply created the node points, then okay, then once again I simply create the some mistakes is there. Once again I create this point, beam joints. I create this points and create this points and this point and this point. Yeah, now it's correct. Now it's all points are correct, right? Something your node will be confused for you. So you simply draw this bottom geometry method. You will be refer the dimensions also, right? Simply refer the dimensions for your beam, right? Our node step is over. And then how to create the node numbers? Simply go to labels, then go to node numbers, apply, okay, right? My 12 columns, right? Simply created the 12 columns. Then how to increase the height for your building, right? How to increase the height for your building? Simply go to, first of all, select your node numbers, right? First of all, select your node numbers. Simply select the node cursor and select the node numbers, right? Select the node numbers, then go to geometry, okay? Then go to geometry, then go to translation repeat, right?
then go to translation repeat, then go to y direction. Already I told that yesterday class, x is the length, z is a width, y is a height, right? Y direction. My spacing is a height for my building. You will be rear structure means the ground level is there, then your brick level, road level, then your building, right? You provided some grade beams are there, right? So I simply provided the 14 feet. I simply provide this. See how to provide my bin feet, right? This is our small reference. This is our building. This is our ground area, right? This is our ground level. Ground level for my building. This is a footing level. This is a ground level to footing level. Then ground level to basement level, right? For the road level. My road level I taken into 4 feet for my building. Then this level to plinth area to my total building is a 10 feet. Totally 14 feet for my building, right? Some of the building has something height from the road level, so I provide the height for road level to our building is 4 meter height, then our built up plinth area to roof level is a 10 feet, totally 14 feet for my building, right? The number of steps I need a only one floor, simply click this only one, already one there, right? That option link steps means simply see this, I go to y direction 14, number of step is 1, right? Give OK. Automatically create the node points, but do not link this 2 points. How to link this points means simply select it, then go to geometry, go to translation repeat, y direction 14 feet, one link steps, right? Link steps, okay. Now it's see automatically your column number will be join, right? Then you join the beam numbers, right? Beam numbers, simply go to geometry, go to add beam from point to point, right? This automatically I will create the for different types of slabs for your use. I simply create the first one is square slab. It's converted into one way slab, right? This is a bedroom. This is another one room, right? This is another one room. Then this is another one. This small. It's created as something one way slab and this two way slab. You need you will be provided. Otherwise you will be deleted, right? I do not this column means is converted into one sorry secondary beam, right? Secondary beam. We provide the directly this beam is provided on this main beam. Sorry, yes. Yes, சொல்லுங்க. Yes. சொல்லுங்க சொல்லுங்க. Yes, சொல்லுங்க. இல்ல அது நீங்க வந்து இதுல வந்து கன்வெர்ட் தான் பண்றீங்க ஆக்சுவலா. அதுல வரும்போது உங்களுக்கு ஆட்டோமேட்டிக்கா என்ன எடுக்கிறீங்களோ அது கன்வெர்ட் ஆகி வந்துரும். இப்ப நம்ம ஃபீட் கன்வெர்ட் பண்ணும்போது நீங்க கடைசி அந்த டயகிராம் போகும்போது அங்க என்ன என்ன டயகிராம் வச்சீங்களோ அது ஃபீட்டுக்கு ஏத்த மாதிரி உங்களுக்கு வந்துரும் இன்ச்சுக்கு. சார் 3.75ங்கிறது எனக்கு நீங்க வாலோட சென்டர் டு சென்டர். ஆ ஆ ஆ ஆமா சார். அப்ப அதுல ஹாஃப் வரும்போது உங்களுக்கு காலமோட ஹாஃப் இங்க 4.5. ஆ நீங்க காலமோட சைஸ் அது மாறும் சார். நீங்க அந்த காலத்தோட சென்டர் லைன் வைக்கும்போது நீங்க மாத்திக்கலாம்.
இப்போ நான் 9 to 9 வச்சனால அந்த காலம் சைஸ் அதோட சென்டர் வந்து ஆட்டோமேட்டிக்கா மாறிக்கும். நீங்க எப்படி எடுக்கிறீங்களோ அதை பொறுத்து சென்டர் லைன் மாறிக்கும் சார். நீங்க காலமோட சைஸ் ஆக்சுவலா ஃபிக்ஸ் பண்ணணும். ரிவீட்ல வந்து அதோட வீடியோஸ் என்னோட யூடியூப்ல இருக்கு. நீங்க அதை சொன்னா ரொம்ப டைம் ஆயிரும் தான் நான் 9 inch by 9 inch முடிச்சிட்டேன் சார். அதான் நீங்க அதுக்கு ஏத்த மாதிரி நீங்க மாத்திக்கலாம் காமனா. ஓகே. ஆமாங்க சார். சார் அந்த அளவுக்கு நம்ம டீப்பா நீங்க கேட்குற அளவுக்கு டீப்பா பண்ணணும் ரொம்ப இதாகும் சார். காலம் டைம் இது ஆக்சுவலா சும்மா இதுக்கு மட்டும் தான் ஃபர்ஸ்ட் எப்படின்னு தெரிஞ்சுக்கிறதுக்காக தான் இது பண்ண சார். நம்ம அந்த அளவுக்கு டைம் போடணும் டைம் இது அதனால தான் சரி ஓரளவுக்கு மட்டும் பேசிக்ஸ் ஃபர்ஸ்ட் தெரிஞ்சுட்டு அப்புறம் இது பண்ணிக்கலாம் அப்படிங்கிறதுக்காக தான் சார். ஓகே. இட்ஸ் ஓகே. தேங்க்ஸ். Then I simply created the one framed structure, right? Thanks. Then created the framed structure. Simply go to geometry, translation repeat, then y direction, number of spacings and steps, right? Then I simply created the one framed structure. Then go for general, right? The same procedure, material, property, support and load and condition, right? First of all, I simply created this one framed structure, right? I converted as an assumption structure, not a correct structure. I simply assumption that I converted square slab, one way slab. This is our square of square. This is a rectangular slab, right? Okay. I show that some dotting and column marking for your plan, right? Before you column marking and plan. What is that? First of all, yeah. First of all, what are the code books are you refer to design in your framed structure, right? What are the code books to design in your framed structure? First of all, the National Building Code of India 2006, you refer for this code book, right? The next one already all are known about IS 456 2000, right? IS 456 2000. Next one is the IS 875 part 1. Yesterday will I deeply explain about for my dead loads, right? Today we'll discuss about IS 87 part 2 for live loads, right? Live loads for slabs and others, etc. The next one is the part 3. This load for wind loads, IS 875 part 3. The next one IS 875 part 5. That's loads for your combination and vessel loads. These are the main code books for design your structure. IS 875 part 1 and part 2 for live load and part 3 for this type of wind load and part 5 for vessel load and combination, right? Next one, designing aids for reinforced concrete IS 456. This basically all are known is designing for beams and columns, right? The next one is the SP34. This is handbook on concrete reinforcement and detailing, right? Next one is the causes and prevention of cracks, right? This 16700 2017. This is for tall structures, right? Next one is the earthquake. This is a ductility detailing, right? The next one is the structural planning for your RC building. Some of the conditions is that you're planning for your RC building. First one is the positioning of column, right? Positioning and orientation of column. So what are the conditions are there? The first condition is that you provide the near the corner of the buildings, right? The first condition is the near the corner of the building. Next one is the intersect the beams and walls. Next one, avoid the projection of columns outside the wall. Next one, depth of the column contained with the major axis. This point is the main point. Depth of the column with the major axis means the column depth is provided for the longer span side, right? You will be maximum orientation is there. Column will be orientation. Depth is there. Orientation means this main condition. The column width is 230, the column depth is 450, right? The 450 side provided for longer beam side, that is a main condition. And one is that condition, another one is a loading condition. Two conditions are provided for column combined with the major axis, right? This is the main condition. Avoid the largest center to center distance and column on property line. I tell about later what is meant by column on property line. This is the main condition for designing orientation of your column. Depth of the column contained with the major axis. You provide the column depth in your longer beam side, right? The next one is the rules as per IS 856 sticks for your column design. I tell about later how to design. I tell about the column design, right? This is a condition category of our column. How to design the column means some categorization is there already known. Axially loaded column, axial or uniaxial bending, center column or loaded or biaxial column. These are the main columns. What are the loads on conditions, right? First one is a loads on column. You design the column means consider the loads, whatever loads will be in your column, right? That is a loads on your column. The next one is a moment. Which moment we will be coming in your column line, whichever you will be coming in your column. The next one is the effective length. Already you studied effective length. And type of column, the short column or long column, biaxial column, and then grouping of columns. And next one is the designing of column section. These are all categorization of the column designs, right? One is the how many loads will be considered on your column, then moments will become what is the effective length, what type of column, short column or long column or biaxial, anyone, then grouping of columns and design the column section. There is the main condition for your column design, right? This is some of the already known, the top story, intermediate story, and the column and bottom story, the effective length will be taken, right? It's okay. Next one is the what is meant by reduction in imposed loads? Anyone? Some of the criteria is there. IS 875 part 2. The imposed load for our floors. What is meant by imposed loads on floors? Anyone? To reduce the column load by floor. That is called imposed load, for your reduction in imposed load for your floors, right? You studied in IS 875 part 2, right? You simply design the G plus 5 or 6. See that this is the main condition for your column design, right? The following condition is only for columns and load bearing was piers and support for foundations only. This condition will be applicable, right? What is this is the main important for your column design. This is the number of floors, right? You go to first floor means no reduction. The first floor means top proof, right? So no reduction. You go for second floor means you reduce the 10% of the load from the column. You go for third floor 20%, fourth 30%, 5 to 10 you reduce the 40% of the columns, right? Not a earthquake condition, is a normal condition. You reduce the column load on the column. Over 10 floors you reduce the 50% of the load of the column, right? This is a small charts for this. This chart is taken from IS 875 part 2, right? This IS 875, the part 2 is the column, this is the first floor on the roof, is taken into roof thrust, no roads or reduction. This is the second floor, right? The first floor is considered as the second floor. So total load is 30 plus 40 is a 70. Simply 10%. Total load is a 63. You go to after 10th floor, reduce the 40%. The total load you will be reduce the 40% for this column, right? This is the main condition to reduce the column load in IS codes also recommended for reduce the column loads only for column loads only, right? This is the main condition. You go to next third floor, you reduce the 2% or 3%, 4%, and go to after you go to 5 floors or 10 floors, you reduce the 4% and 50% of your loads, right? Now understand.
This is a main concept. It's taken from IS 875 part 2, live load reduction for your column, right? This is some of the axial, biaxial, uniaxial column. The axial column means this one column is there. The four beams are joined, right? The four beams are joined. This to this beam is moment will be transferred. This to beam is the moment will be transferred. The axial column means only the load will be there. Moment will be less. Why? The beams are transferred. This beam to this beam, this beam to this beam, right? The moment will be less. You already studied DRC, right? This is a biaxial column. This will be two beams are there, right? But the load will become two moments will become this beam moment directly carry over to column, right? Then this beam moment carry over to column, so this column will be provided for two beams. Then this column, this beam is transferred to this side, this beam is transferred to this side, right? Moment, but this beam is moment transfer to column, right? There is a small difference between Axial, biaxial and uniaxial. You already studied in designing subjects. There is a MUX and MUY axial load. That is the axial load column. The moment will be less. But the biaxial, uniaxial, the moment will become single moment and two moment. That is a condition. This beam and this beam, right? This beam moment transfer to this side. This beam is moment transfer to this side. But that beam, the moment transfer to no beam in opposite side, corner column, right? Corner column, but so that beam is moment transfer to that column, right? Now understand, that is a basic condition for your column design, moment conditions and others, etc. Same concept. Our beam depth is a beam width 230, our beam width is a 440, right? The orientation, I simply orientation to fourth depth side, longer column side, I provided a longer beam, right? Now understand, there is a concept I told about the first slide, the major axis. This is a condition, the column depth orientation to longer beam side, right? Now understand. Okay, this is a basic only. Next one, this is a basic condition for column width and column depth for your column design, right? The next one is a column reinforcement detail. I take some reinforcement detail for shown you. The SP34. Yesterday we will tell about the reinforcement detail code book, right? See this. Yesterday you will be anyone. You will be design the 2 bars or 4 bars only your code book, right? You will be design the 16 bars or 12 bars, L-shaped columns or I-shaped columns. You will be design the this discuss. Yes, ma'am. Yes, ma'am. Okay, sir. Ma'am, now is visible, ma'am. So now the screen is visible. Okay. You go to for two rebars, this 4 members. You go for as usual. You go for 16 bars and 20 number of rebars. L-shaped column and Y-shaped column. How to provide the reinforced SP34 code book, right? Code book. Simply you refer the SP34 code book. All details will be come how length, how many are to another rebar and angle size will be provided anyone. Angle size will be provided anyone, right? This is a column longitudinal detailing reinforcement area, right? This is a bundle bars. The bundle bars already known about bundle bar concept. The bundle bars are the heavy rebar area. You provided the bundle bars. The 2 bars are bundled with our columns, right? There's a beams also provided the bundle bars.
This is one is a floating column. Different types of column. This is a floating column. Different types of column. This is a floating column. Same like that. This is one of the field column. Is have 16 reinforcements. He provided this type of ties. This refer from SP34, right? You simply refer the SP34 code books, right? Different types of columns, right? Yesterday we'll discuss about the categories of beams and other conditions, simply supported beams and moment distribution sums, etc., right? And what types of beams will be used in our field? Yesterday I will tell about the conditions, minimum reinforcement for your beams. The when will be provide the side reinforcement for your beam means the more than 70 mm your beam depth, you will provide the side reinforcement, right? You will be provide the side reinforcement. Okay. Yesterday we will tell about this, a cross section for your beam. I take this moment, this type of moment and this type of moment. You provide this tension compression zone. Tension zone will be high. The compression zone it will be high. The compression zone it will be high. This is the basic things for your reinforced beam, right? The next one is a what types of beams are using in our field. First one is a secondary beam, right? This type of first one is a secondary beam. The second one is a hidden beams. The hidden beams are provided for slab. Reduce the thickness. Reduce the thickness for your slab means provide the hidden beams. The hidden beam detailing diagrams. This is the inverted beams. Anyone known that inverted beams? What purpose we provided the inverted beams in our field? Anyone? Inverted beam actually has a normal beam, but what purpose we provided the inverted beam in this top? For this, see, this is a slab, right? But the beam is provided in this bottom, but the inverted beam, the slab is in bottom but beam is sorry high, right? Why? The mainly the inverted beams are normal beams. The inverted beams are provided for architecture purpose, right? Basically you starting your design, what are the like how much secondary beams and hidden beams for your beams, inverted beams. The mainly the inverted beams are provided for your architecture purpose. This is one of the building under construction. This is automatically top of the slab, right? This is an inverted beam for architecture purpose. You will be design before you starting your design, what area will be inverted beam will become secondary beams and hidden beams you will be planned first only, mainly provided for this bridges and others, etc., right? The next one is the bundle bars. Already told the bundle bars, the maximum reinforcement will become slab bar columns. It provided the bundle bars, 2 point will be jointed. To refer the SP, the beam detailing, how to find my beam detailing column and others, etc., you refer the SP34. You provide the step-by-step procedure for this beam detailing, right? Now understand the column detailing also, you provide the step-by-step procedure for this SP34 and beam detailing also, right? The next one is a spanning of slab. Okay, the spanning of slab is a condition is the same slab condition. One is a simply support one end is continuous to other end. Slab contains to both end and miscellaneous, right? Okay. Okay, slab will discuss on tomorrow, right? Same like that. Okay. The slab will be same as a reinforcement details and other details will be taken on the SP34 code books, right? Okay. Day after tomorrow discussing on footing also, right? Now understand how to classify your columns or short column or long column, biaxial, unicolumn. What types of beams will be provided for inverted beams or secondary beams and other beams, right? Okay. This is small PPT. No time. I simply completed. Okay. Then go for start. Then I design the one simple how to apply the dead load and live load for your different types of slabs. This is a one-way slab, right? How to apply the brick loads, dead load, slab live load, and others, etc. Right? Simply go to First one is a general, go to material, concrete, assign to view, assign, yes. It's the basic steps. Simply assign. Next one is a property, right? Next one is the property. The first condition is a what condition? You provide the property, right? I simply for the beam property, I simply provide the feet. I have some confused, right? Simply go to set current into units, meter into kilonewton, okay. Then go to define rectangular or column is a 0.23 into 0.8, right? Add this is a column size, okay. Simply see this column size. How to apply the column for this size means select, go to beam Y, right? Assign to selected beams, assign, right? Then go to 3D view, right? Then go to 3D view. This orientation, this type of longer beams comes, you provide the L-shaped columns also. You will be provided the L-shaped columns and other shaped columns. You will be provided a manual calculation also, right? But your beam depth is there provided for longer columns, right? Longer beam sides. Already this all are provided this column for longer side. This is the correct, right? This is the short side. This is also longer side. Automatically our beam depth is provided for longer side. See this? I created another one size. Go to rectangular 0.2 0.38 by 0.23, right? Add is automatically this column. I change this column, right? Saying yes. See this. This column orientation is correct or wrong? Anyone? This two column orientation is correct or wrong? Anyone? Second and third column orientation is correct or wrong? Anyone? How? This column second and third. So the maximum depth is comes from shorter span side, right? Our rule is the depth portion is and comes from longer span, right? Longer span of the beam. Yeah, already I tell about the first slide, right? The maximum beam depth will be orientation into longer side of the beam. But now it's correct or wrong? This column and this column. This column orientation into shorter beam side. So it's wrong. It's converted into this beam depth is orientation into longer span. That is the correct one, right? I simply click this, assign yes. Then go to 3D. Sorry, oh, it's not changed. Go to property, assign to view, assign yes. Sorry, this two column only, right? I need a column only. Click and click this. Yes. Then click this. Now it's correct or wrong? Simple orientation. This is a basic condition. Now it's two columns are correct, right? It's a longer span of the beam. The column orientation into longer side. This is a correct one. This is the orientation. The main orientation for your column side. This is a condition, right? Next one is a beam size. I simply go to rectangular. This is simple ground floor only, but the beam size is different. So you go to thumb rule, 2 or 3 beam sizes are will become, right? I simply take a only one beam size, 230 by 300, right? So I apply on my beam. Simply go to select beam, go to X, go to Z, right? Assign yes. This automatically created the beam column in our conditions, right? Then second step is over. I creating the property. The next step is a support, right? Support. Creating the support. Simply go to create fixed add. How to apply this supports for this all the bottom condition? Simply go to
This is isometric view. Simply go to Z view, right? Simply apply all the bottoms, assign yes, right? Assign yes, then 3D, right? Assign yes, then 3D. Will be change the all the conditions, right? Simply apply this columns. Then next one is a properties over, support is over. Next one is a load and definition. This is the main concept. Yesterday we'll discuss about simply UDL. Today we'll discuss about UDL load, floor live load, and floor dead load also, right? First of all, simply go to load case 1, go to add. I take a dead load, add, then dead load on brick load, dead load on slab load, then live load on slab, right? How to change the names means simply click this load case 1, right click, sorry, go to edit, this is self fade, right? Self fade, change, then this is the edit, is my brick load, brick load. Next one is I put the slab dead load, dead load. Next one is a slab live load, right? These are the basic conditions. Slab live load change, right? Then how to apply the loads for your building? First one is a self fade. Simply click this, add, self fade, add, self fade, assign to view, assign yes, right? So self fade. The next one is a brick load as per IS 875 part 1, right? Yesterday we'll discuss about IS 875. Simply go to add. I take a member load uniform force. I briefly discussed about yesterday how to calculate the brick loads. I simply take 15, add, close. How to apply the brick loads for my beam? Simply go to slide, go to X direction and Z direction, right? Then assign to selected beams, assign, right? Like this. The next condition is a slab dead load, right? Slab dead load means how to create the slabs. First of all, conditions is there. This is square slab, one way. This is a two-way slab. This and this is a square slab, right? How to create this slabs in one way and two way and three way slabs, right? The simple method. First of all, you created the slabs, right? Simply go to grouping method, Control Z, right? First of all, select this. This all are come from square slab, right? I simply select this all the beams. See this. This is square slab for my beam, right? Simply select this. Control Z is a grouping, right? Control Z is a grouping. This is slab. Square slab means S2, right? Go to simply go to floor, right? This is a floor load. Okay. Then go to associated to selected geometry, associate, right? Automatically the square slab will be associate. This is a one way slab, right? Simply select this one way slab portion, Control Z grouping, create is a one way slab, right? One way without spacing, one way, right? Then go to floor, right? Then go to floor, okay. Associate with selected geometry. Associate automatically created the one way slab. Next one is a two way slabs, right? Two way slab. This is a two way slab, longer slab. Simply click this. Yeah. Okay. Once again, I realize something is problem. Once again, simply go to grouping. First of all, you select this beams, click this and force size for this
two-way slab. Simply go to Control Z, create two-way slab, flow. Sorry, yes, thank you. Then go to Control Z, go to create two-way, right? Then go to floor, okay. Then you go to some problem, some deleted, right? Once again, I will be create. Click this and click this, right? I create the one way. Simply select this one way slab. Go to Control Z, create one way. Go to floors, okay. Associate. The next one is a square slab. These are the same like a square slab. This portion and this portion. Control Z, grouping, create. These are the square slabs. Simply select as a floor, okay, associate. Now it's separated into square slab, one way slab, and other slab. That is the easy method, right? Then how to apply the loads for my floor load for my building? Simply go to slab dead load, add, right? Add. This my dead load is how to calculate the dead load. Unit weight of concrete into overall depth of the slab, right? Unit weight of concrete into overall depth of the slab. My assumption, my overall depth of the slab is 0.13 meter, right? Into 25. My self weight is a 3.25, right? How to apply the 3.25 dead load for my square slabs? Simply go to load case, go to floor loads, right? Go to floor loads, it's a minus 3.25 plus add the floor finish also, right? The floor finish is 0.75 to 1.5. I simply add minus 4.25. Our dead load is a 3.25. Our floor finish is a 1 kilonewton is a 4.25. Next grouping. My square slab included floor. Add close. This is automatically created as a floor like a fire slab, right? The next one is a one-way slab. I created the one way. One assumption is a one-way slab thickness is a I provided 150 mm. It's a longer slab, right? 150 mm thickness for my overall depth. 150.15 into 25. My self height of the one-way slab is 3.75, right? 3.75 slab load. Simply go to floor load minus 3.75, 4.75 plus floor load also, right? Go to group, one way slab, included floor, then another one option, you pick the one way distribution, right? You do not pick wanted as a two way slab. You complete distribution, add close, right? This is a distribution. The one way load taken into longer beam only. See, automatically the one way load is distributed into longer beams, right? This is the condition for all the floors, right? Next to two way slab. Simply go to our two assumption as a 25, right? 4 kilonewton per meter. Go to add, go to floor load 4 plus 5, right? 1 kilonewton per floor load. Our dead load is a 4, floor load plus 1, 5. Simply go to group, go to two-way slab, included for, do not tick this one-way distribution. Add, close. Click this once again. Two-way slab, same position. Floor, okay. Associate, close. Then go to slab dead load, slab dead load, add. Then go to floor load. The total load is a 5. Then go to group, to included floor, add, close. Now it's automatically created as a two-way distribution, right? Now understand, you studied in book, right? Yield line theory. same pattern will follow on this stat row also, right? The same pattern. See this automatically the square is the in our my YouTube channel is there. How to calculate the manual and stat row also load calculation. One way slab and two way slab also. You will study it. Is useful for you, right? You see this automatically is converted as a two-way slab. This is a one-way slab load distribution. These are the square slab. Now only I apply for my dead load only. Then how to apply the slab loads? Anyone? How to apply the slab loads for my building? How to take the slab loads? Anyone? Anyone? How to apply the slab? No, the load distribution is the yielding theory. It's correct. Applying on load 3 kN per meter square. How to apply that 3 kN per kilometer per meter square? Where did this taken? That live load value. Where the values will be taken, live load values. 3 kN per Newton, 2 kN per Newton, kN per meter square. Same as the IS, ah, IS code. Yes. IS 875 part 2, right? Your live load is the IS 875 part 2, right? IS 875 part 1 is the dead load. IS 875 is the live load, right? This automatically is a all the is a residential building, right? This all rooms and kitchens are 2 kilonewton. The corridors and passage are 3 kilonewtons. Balconies are 3 kilonewtons. And you got different types of education building. The education building is the classrooms are 3. So why the dining rooms are 3 plus? Anyone in live loads as per IS 875? The classrooms are 3 kilonewton, but our dining rooms are 3 plus, our office rooms are 2.5. Why? Our classrooms are only 60 to 70 students, but dinings have 200 students or 150 students at the same time. The office rooms are 2.5. The 2 or 3 stops only there. That is the difference between the loads in live load. You give the different loads for different slabs. You give the 3 kilonewton, 2 kilonewton for the office rooms and dining rooms for the 3 kilonewton and the classrooms for the 3 kilonewton. Right now, understand? As per IS 875. I give the square slabs for 2 kilonewton. The live load for 3 and square slab for 3, 2.5 for one way slab and 3 for my two-way slab, right? As per IS 875. Simply go to live load. Once you created this group, it will be easy. Simply go to floor loads. My live load is a square slab is a 2 kilonewton. Go to group, go to our square slab, right? And close. This automatically our live load will be created. Then go to slab load. Then go to floor load. Then one way slab is a 2.5. Then go to group one way. Simply click this distribution. Yeah, correct. Thank you. Minus 2.5. Add. Now it's I created the live load. Then simply go to rectangular slab. I created 3 kilonewton live load. Minus 3 group two-way slab. Right. Add. This automatically I created the one-way slab and two-way slab and other slab, dead load and live load. A brick load also not a common for all this. You created the 3 or 4 brick loads will be come in your building, right? 3 or 4 brick loads will be come in your building based on your size, etc. Right? Okay. Now understand how to give the different floors for the different loads, right? Now it's completed the self load, brick load, other than UDL load, slab, dead load, and slab live load for IS 875. Next one is the combination for my loads, right? How to see the values for my
live load for this portion and dead load. Simply right click, labels, load values, apply, OK. See this load distribution values for this rectangular portion and a triangular portion, trapezoidal portion for this loads distribution, and one-way slabs also, right? See this. Automatically you see the distribution for this loads. The next step is a combination step, right? Simply go to load cast detail, add, define combination, step into this step, all now converted into 1.5 or factor of step day 1.5 times of my material, right? Simply add, close. Now it's automatically all the size will be increased, right? Then our material is over. Material property supports load and definition will be completed for me. All the load case, self weight, brick load, this is basics only. Dead load, live load as per IS 875 part 2 part 1 1 for combination part 5, right? Now itself I completed. Next step is the analyze, add, analyze, run analyze, save, right? Our first modeling step is over. Right? The properties say number is not entered in some. Yeah, I simply created these two numbers. That is a problem. You will simply go to material, concrete, assign to view, assign. Next one property. I not apply this material for this property. That is the error value. I simply click this, then assign yes. Then go to analyze, run analyze, save. The error will be 0. The warning will be 15 warnings. The property numbers are not under duplicate values. Okay. Okay, there is no problem. The one more time I deleted. The property members are is not a problem. Yeah, property numbers are entered. Sometimes you will once you delete it after you enter, that command will be given, right? Okay. Then next to go for post processing, right? Post processing, which load will be taken? Combination load will be taken. Simply OK. Then you go for deflection. Next one is a bending movement, right? This is a huge bending movement will become. Yesterday we'll discuss about small bending movement, but today we'll learn huge bending movement. For the span is high, the load will be high, right? This is bending moment value. Go to result, view value, beam result, bending moment, right? This is automatically 129.74, 172 is a beam. The value bending moment is high. So you reduce the sizes or reduce the beam span sizes, right? You will be reduce the bending moment. Also increase the size, you will be reduce the bending moment, right? Okay. Next one is a shear force. F is that. The shear force also high, right? How to see the values means simply go to result, view value, beam result, same. Okay. Our shear value also high. Our beam span is high. So the shear value will be high. You provide the high reinforcement or increase the beam depth also, right? Increase the beam depth. This is a maximum 20 feet, right? 20 feet means 20-inch beam. 20 inch, more than 1 feet 9-inch beam, right? I provided only 1 feet 6 inches. So it will be high. To increase the beam depth is also as per thumb rule. How to see the footing loads? Simply go to reaction. This is automatically our footing loads. This column is come from this two beam load only 96, and this column is 236, this column is 166, this column is 396. So this three beams are comes under this column. This beams also 241, and this beams also moments and will come. You simply design the columns and beams, right? Okay, now understand. Simple method, simply created the one 3D structure. Then how to separate the load for my rectangular slab and other slabs for this structure, right? One way slab and two way slabs, right?
Then how to design your structure, right? Simple method. Simply go to design, go to concrete, go to IS456, go to select properties. Yesterday we'll take an compressive strength and reinforcement, right? Okay, I change the units, set current input units mm into Newton. Okay, define parameters, take this 25, same yesterday, same procedure, 415, 415, right? Close. I will apply for the all. You take the column properties, so many properties are there. I will be tell one by one. Assign for all materials, assign and assign. Then go to design the beam and columns. Simply go to commands, add beam, add column, add take off, right? I added three properties. Then design beam. Simply select this beam. Go to select beam parallel to x direction. Select beam parallel to z direction. Assign to selected beams. Then select beam parallel to y direction. Design column. Select this design column. Select beam parallel to y direction. Assign yes. Then go to analyze. Before you close that, analyze, run analyze, save. Then you see this beam values. Double click this. This is the first one. You check this, which beams are designed, which beams are not designed in your building. This beam is designed. First, this beams also designed. This beam also designed. This beam is not designed. Why? The size is too large and loads are too large. So increase the beam size. This beams also designed. This all the beams are designed. You check the column, right? Click this concrete design. This column will be plus. Check this column. This column is not designed. There so many loads are will come and moments also come, right? This is the axial column. See this automatically the four beams are acting on this column, so it's not designed. So you will be increase the column size. This column is not designed, so increase this column size. This column also, right? Then click this column, automatically it will be designed, right? Okay, so okay, this is the method for designing your beam column. Then how to rectify this, beams and columns. This is a small check for your IS456. This is the conditions, right? The cross section as per IS456, the cross section longitude not less than 0.8 percentage, more than 6 percentage. The four bars are rectangular, 6 bars are circular. The bars to not less than 12 mm. The helical not less than 16. The spacing not exceed 300 mm. Larger bar not spaced more than 75 mm. The corner sides are provided higher dia bars. That is a condition, right? See this first one is a column condition. This is a load for this column. The moment, two moments for this column. Then this is the grade of concrete, grade of steel. This is a AST. This is a percentage. The minimum percentage is a 0.8. The maximum percentage not greater than 4 percentage for framed structure, 6 percentage for pier. This is the minimum is a 0.5 is there. You convert it to 0.8 for minimum, right? Click this, automatically this percentage is a 0.5. You convert it into 0.8, right? But this column is not designed. Simply go to general property, right? Define rectangular, mm is there, right? I give 550 add for this column. Yes. Simply go to analyze, run analyze, save. I change this one column only. Then click this is not needed. To increase the column size also. This is a not increase. Simply go to properties, edit, more than 600 mm, right?
No, the more than column, but the span is too high, right? So the span is not designed. It is our span is a 5 meter. 5 meter means 18 feet. Right. To increase this column also, it's automatically it will be designed, right? Tomorrow we'll discuss on briefly on how to rectify the column designs and beam design from this load and others, right? How to check the minimum reinforcement, maximum reinforcement, and detailing section. Okay. How to pass the all the beam section in our stat pro. Tomorrow we'll discuss on the same diagram, right? Okay. Now I completed this section. Any doubt you will ask me directly. Okay.
Thank you so much, Biaxial, sir, for your excellent presentation. I hope everyone get benefit and we have learned today. It will help for us in future. Whatever project we have, we get some confidence to implement that project for your presentations. Thank you so much, sir, for your wonderful delivery. Today, person is on how to analyze the structures for framed structures, how to do calculations, with everything, each and everything very clearly, and get some idea about that, how to analyze that for the framed structures. Thank you so much, Udayashankar sir, and also thank you so much for all the participants for your patient your attention. Participants, if you have any doubts, please unmute your mic. You can ask your doubts. And also, I have posted in the feedback form. All the participants are requested to fill the feedback, the valuable suggestions on this webinar series.
Progress, I put the feedback form on YouTube live also.
Yeah.
Oh, okay, sir.
If you have any doubts, please unmute your mic. You can ask your query. Then otherwise, you can leave the session. Thank you all for the participation. Today's session. We will meet again tomorrow at 7 p.m. Tomorrow, our research session discuss about the analysis of the stress by using the stat pro, and then continuous these parts also. Thank you all for participating. Today's session will tomorrow. Now you can leave the session.